In this experiment, I will explore the relationship between the surface roughness and hydrophobicity. The Wenzel model can be used to describe this relationship between surface roughness and hydrophobicity. As the liquid penetrates the rough surface, two angles form, an apparent contact angle and Young's contact angle. This Wenzel model is governed by equation 1, where theta W is the apparent contact angle known as Wenzel angle. R is the ratio between the actual and projected surface area, and theta Y is the Young contact angle. The materials needed for this experiment include silicon, 60, 400, and 3000 grit sandpaper, water, dropper, protractor, camera, glass slide, and isopropyl alcohol. The procedure for this experiment goes as follows. First, spread silicone on each grit of sandpaper to form a round silicon patch. Then spread silicone on a glass slide, forming a round disc as well. Then let the silicone dry. Once dry, gently remove silicone from the sandpaper and glass slide. Then rinse each silicone mold with isopropyl alcohol to completely clean the surface of each mold. Then place 2 drops of water on each silicone mold. Take a picture of each water droplet on each silicone mold. Finally, measure the contact angle that each droplet forms on each of the silicone molds. These pictures represent the different drops on the silicone molds. 2 drops were placed and measured on each different grit. On the left shows drops on 60 grit, and on the right is drops on the 400 grit sandpaper mold. Here are more pictures with drops on 3000 grit on the left, most pictures, and drops on the smooth glass surface mold on the right, most pictures. I measured each drop's angle on the left and right side of each drop. Pictured below is the measurements of each angle on the left side of each drop. I first averaged out the measured angles to get an average apparent angle. I then rearranged the Wenzel equation to solve for the roughness coefficient. Then I plotted the roughness coefficient against the grit of the sandpaper. This plot represents the relationship between the grit of the sandpaper and surface roughness. It can be seen that as the grit of the sandpaper increased, the roughness coefficient approached 1, which means the surface becomes more hydrophobic. Also in the calculations, the contact angle increased as the grit of the sandpaper also increased. In conclusion, it was found that the surface was becoming more hydrophobic as the roughness approached 1. Some errors in this experiment could result from the assumption that the smooth surface was ideal and that the smooth contact angle was the Young contact angle. One issue was that the drops were not all the same size. Another issue was that the silicone was not perfectly flat and it was flexible, causing the drops to be asymmetric. Also, it should be noted that the 3000 grit was so fine that not all the silicone could mold, causing it to act like a smooth surface, and this is why its roughness equaled 1.